Thank you, Diana. Good morning, everybody. Thank you for joining me on this cloud and blustery day, this sunny and blustery day in Chicago, for the Don't Trust the Word Cloud webinar. Uh, I, it, this has been sitting in top of mind for many, many months now, as far as what to believe and what not to believe in the word cloud. Many of my customers have come to me and have basically asked me, so what do you think about the cloud initiative or cloud services? And it's gotten me thinking, maybe there's some room for thought and room for exploration of when is it required, when is it useful, and certainly what is actually happening out in today's market. Another thing that got me thinking was the many commercials that are sitting out there, and they kind of discuss the cloud, and to a certain effect also kind of minimize its impact on the environment. It shows all of its usefulness, but not necessarily all in the correct ways. So I think in some form or fashion, we're also being kind of led down the rabbit hole, so to speak. And it kind of begs to ask the question, what really is what is really the cloud for my environment? And a cloud can mean anything to anybody. So those are the topics that we're going to be discussing, and also kind of address, and talk a little bit about the security about clouds. Now, many of these opinions that I have here today are based solely on my experience with cloud-based computing, and also as sitting on the infrastructure side and deploying the services and the pipeway for supporting cloud-based initiatives, whether it be in a data center or a private cloud, for that matter. The other comes from basically talking to industry pundits and discussing these topics with them, and also using some of their supporting information. So you'll see some of that here. So without further ado, we will begin. I know your time is precious. Thank you so much again for joining. If you have any questions, again, direct them at Diana. She'll post them, and if I can answer them right away, I will try to. If not, we will get an answer back to you. Okay. So this pretty much sums it up as far as, am I the only one who's ever had the urge to punch myself in the neck whenever I hear about the cloud? The cloud has been around for a while. And actually, if you harken back to the late 90s when SETI was just starting to come on board, and everybody was using SETI, everybody was talking about grid computing and using the power of multiple PCs and the multiple machines from across the world to go ahead and provide that processing power and compute power to discover alien life forms and so forth. That somehow has been morphed into cloud computing, and everyone's understanding is like, oh, it's a bunch of computers that are connected to each other, and they all share each other's services. Somewhat true, but somewhat also false, especially when it relates to building your own private clouds, and also when you go ahead and start renting your own public cloud. First, what is cloud computing? Cloud computing, in essence, and I think from everybody's relative understanding, is a pooling of resources and being able to access those resources from anywhere, anytime, any place, and it being scalable and cost-effective. Couple things of note, and we'll touch on those as we get down through the slide deck, are that one, it isn't as simple as just waving a wand and poof, there you go. It can be with the proper preparation, and two, understanding the impact on the environment that you're developing the cloud for, and the impact to the end user. At the end of the day, it's about supplying the information that is requested of by our user base, and getting it to them in a relatively short form and fashion, while remaining competitive and cost effective. So I like to use the simple analogy. So you say you just moved into a city and you're looking for a place to live. So you can either build a house or you can rent a house. Now, when you build a house, you can go ahead and start choosing your options, your flooring, your floor plan, your windows, your tiles, your lighting, your landscape. The thing is that you also have to sit there with a planner, somebody who's actually going to build this thing for you, because 9 times out of 10 you may not have the necessary workforce or capacity. You might be fighting fires on a daily basis. You might have other projects that have been on board. You might need to have somebody to come in and work with you to, one, either design do an assessment, or to try just to work with you and write an RFP based on your requirements. But when you get a chance to customize, you customize everything. So in this case, flooring, whether it be the speeds and feeds of your environment, whether it be your server base, whether it be location space, your power, your cooling, all of those things are critical components to building your own private infrastructure. Also, the other key component is location. Just like buying a house or starting a business, location, location, location. Where are we going to house these super-powered computers? Where are we going to house this this virtualized environment? Where are we going to house all of this stuff? You can either have it 25 miles away from your home base, or you can have it across the world. One of the benefits of cloud computing is that you can pretty much host it anywhere. But the caveat to that is, what is the price you're willing to pay for that? Again, it's just like buying a house. You can choose the options, but you go a little bit too extravagant, you may be purchasing something you don't need. So we talk about renting now. So that being the public cloud, going out to EC2, Amazon service or Google, what have you, and having somebody else pre-provision that service for you, and going out and building out that environment that you're so wanting, covet, and need for your organization. However, there are a couple of caveats with that as well, and understanding those will help you further, along your project and your time frame. Just being able to pick up the phone and say I want this cloud, is the initial step. But there's a long process of planning and understanding what is going to sit on that cloud, because not everything is cloud ready. That's the other thing. And I hope I can kind of give you a path to thought on whether or not you are cloud ready. I guess that's another term in being cloud, having cloud ready applications, or having an assessment to be cloud capable. So we look at how clouds are easily formed, and they can be easily constructed when you rent one. So they can be converted 2, 3, 4 units. You can move them in and out. You can build them in this location, across the world, and have it close by to you. Again, it's not your infrastructure, so you have a fairly available means of bandwidth as far as where you want to place this environment. The other thing is you also have a little bit of elasticity, because you're able to kind of grow the environment as you grow quicker, versus hosting your own private cloud. You may not necessarily have the CapEx to go ahead and build that. So with that, you also make fewer, simpler decisions, and you can start with one unit and grow it later, as I was just saying. But you don't have a lot of options to customize it. You may be stuck with the paint that's on the wall, and you may have to accept those those rules and regulations. Again, you're basically succumbing to the T's and C's of the contract, if you will, for the amount allotted of years and allotted space, and then anything above and beyond that is going to cost you additional funds. Now, also, you have to understand you're providing this organization your data, and you have to be willing, and you have to be able to understand that your data is sitting on their secure platform that they're calling secure. It may not necessarily marry with your security ideals and policies. However, if it's a requirement to have this service, then you must be able to play by their rules. So one of the things that bothers me the most about cloud and today in the media is that they often misconstrue on how easy it is to obtain, especially when it's a private cloud. The other one is that it is consumer driven, that they're saying that it's solely a consumer-based opportunity, and that it is a one-stop shop. That it requires minimal investment, and the ROI is astronomical, is what they typically say. And the other thing is that it's secure. Now, I harp on the security basically because I do dabble a lot in the security world. However, security within typical environments is a hard abstract to grasp, and often to wrap your arms around, especially for larger organizations who are spread out across the world. It's even harder when you have to kind of give that secure control when you're outsourcing those types of services. Also, what should the model be when you're actually providing those services yourself in-house. A lot of these virtualized environments have difficulty being able to provide the information to your security environments because they're not made to do that. And the converse discussion is also the hardware and the software platforms that are used to look into those environments are not necessarily up to par or mature at this point. So we're kind of looking at trying to playing catch up with the cloud computing environment, and we're kind of falling behind there in the security. So we're going to talk about that a little bit later as well. So what should it say? So in the past, cloud computing, they would say, no, virtualization is not really the topic of discussion. But the fact is, according to Gartner, it is. It is a de facto deployment for cloud computing. Reason being, it's quick, it's fast, it utilizes that hardware that you that you spent a lot of money on, and it utilizes it to its fullest. So you are getting your increased ROI in the box. However, when you remove a bunch of pancake servers and you shove them into a virtualized environment, have you made the calculations for your power and your cooling? Is all that power and cooling been moved, or maybe you don't have enough power to fire up those those blade chassis that you just threw down in your data center? Consolidation, very much so with virtualization. Centralized services, one place for everybody to come and grab their information. You want to kind of grab control, because in the past, the dogma was we're going to keep our servers separate for HR, we're going to keep it different data centers, we're going to have people access it here, access it there, and everything was on disparate systems. Now what we're asking is for all of those systems to come home to one centralized location or a couple of centralized locations and have it regionalized so that the people can get to that data quicker. There are trade-offs, obviously, because you're looking from being able to have control of where you place that data to versus not having that extreme control that you typically had. Disaster recovery. Cloud services are very good for that. Now, again, it's not all things to all people. That being, your application set may not be ready for the cloud. Not all applications are built to be serviced on the cloud. You have to take a look at the latency and the components that are required to drive that bandwidth and get it down to your user constituency. Otherwise, you're going to have a very poor customer satisfaction rating when it comes to delivery of those applications. Access mediums, you have to explore. What is it that you're actually placing this information on? Are you running it on a blade chassis? Are you running 10 gig medium? Are you running a OptiMan or a Metro Ethernet type of environment? Those are things to consider. And one thing I always like to remind everybody I talk to is latency. Latency, it doesn't matter how far or how fat the pipe you have. Latency, even with the benefit of a load balancer or a web accelerator or content accelerator, you still can't fight that. If you're sitting from one end of the world to the other, you still have that transit. As fast as the speed of light may be, it's still kind of difficult to overcome that the fact there will be some drops. So regionally placing those applications which require certain SLA, or the 5 nines, if you will, going up into 6 nines, you may need to assess whether or not centralizing everything away from where your constituency might not be such a great idea. And again, it does require planning. I want to say that when there is this commercial out there from an organization, well-known organization, that likes to say, you have two individuals sitting in an airport and they're watching, they've just been informed that their air flight has been canceled, and the gentleman, just basically says to the cloud, and then he's basically remoting into his house and watching his services from his house, and the lady says, "Yay, cloud." The problem I have with that is that it's basically, again, it's remote access. It's RDP. Your terminal serving into a box at home, and it kind of misconstrues what the cloud really is about. And it's more about application and content delivery versus just accessing something at home. It oversimplifies it, certainly. The abstract is there, but it really does oversimplify it, and I think it causes individuals some angst once they realize how much due process is required in order to invest in a cloud. So again, for the CIOs, the directors, and those even managing cloud-based services, what does it do? It turns that value prop into a commodity discussion, and it truly underestimates the true impact of deploying cloud-based services, especially when you're doing private. And we'll talk about that in a second. Does it really explain what the cloud, really means? It doesn't, and like I said, it does oversimplify the process. It develops unreasonable or false expectations about cloud-based services, meaning that you expect it to be on and always on, and then expect the quality to be there without a level of certain planning and without a level of understanding of what's required to implement the cloud. That cannot be achieved. It certainly won't be achieved relatively quickly, that's for sure. Doesn't reveal the infrastructure change that is required. This is especially true when you're talking about private clouds. Private clouds involve a great deal of speeds and bandwidth, particularly at 10 gig is the norm when you're deploying these large base chassis. So you have multiple chassis in your environment that you're building these blade servers on, and then the I/O, the requirements, and then you look at the storage requirements. When you bring those components on board to the environment, the networking and switching component and your routing component all of a sudden may become obsolete. Your platform may not necessarily be ready. Those are things that you need to take a look at. Is your environment fully capable of ramping up and able to support cloud-based services, or do you have to build a separate network altogether? Those are the questions that you need to ask of your environment and your constituency. So here are some of the facts that I wanted to show you guys. So about 50% of the world's workloads will be virtualized in 2012, and that's by Gartner. And virtualization is the near de facto architecture for clouds by GigaOM. Security is the top concern for virtualization adoption, and 37% of large enterprises expect to adopt infrastructure as a service, or basically cloud services, in the next year. Now, infrastructure as a service is the actual service that I was talking about as being private. So you're actually going out and you're developing your own homegrown private cloud. I just so happen to be sitting next to someone at a seminar I was at yesterday, and they are a web developer for ERP systems for healthcare, and he was mentioning to me of the struggles that and the cost that he was having when creating his own private cloud. They just developed it, and already it's 15% of his OpEx, as far as building out new services for his environment. Now that's pretty high, considering that that going forward, that number is going to continue to grow. So what happens to the remainder of his capital and his bottom line? What happens to that? It gets bigger, and his margins drop because he has to support this environment. It does cost money to build. Over time, it does get less. However, as new services come online and as newer technologies are born and bred and pushed out into the mainstream, what happens to this this highly touted investment? We go back to 10, 15 years ago, and we were still using mainframes. Whether it be an IBM AS400 and everything was supported to that, or if you were using high capacity web servers, that was hot back then. But look at us now. How many of us have mobile devices, tablets, services that actually use applications instead of just tapping into a server and grabbing that data directly and storing it locally on your machine? It's very rare now to see a device such as an iPad or an Android-based device that actually maintains its own content. It doesn't. The application goes out and grabs that content, pulls it down, and voila. It may have some key, whether it be a cookie or something, but it doesn't really maintain that information. Because if it did, you'd run out of space on your machine. So we talk about software as a service. Finished applications that you can rent and customize. Now we look at something like Salesforce.com or Google. They're fully capable of providing software as a service. The other one is platform as a service. Developer platforms that abstract from the infrastructure, OS, and middleware to drive developer productivity. Again, you're trying to provide the platform so that your developers and your organization can actually go out and build a bit, business and generate our revenue-generating business. So That's one of the other components. And then you have, again, infrastructure as a service. The most widely used ones are software as a service and infrastructure as a service. Platform as a service is coming online now as more and more developers are being hired and more applications are being built, specifically for the mobile user base. So the first customers of cloud that are not typical IT ops. Startups and developers using web at scale, web-based businesses, SAS, SaaS collaboration services, widget providers, obviously those that provide applications, that you can access, such as Salesforce. Small businesses using SaaS, online businesses, they're the first to adopt that because it's easier, it's quicker for them. They don't necessarily have the resources to build their own private cloud, nor would I ever recommend someone, less than 10,000 individuals, to go out and buy and make themselves a huge cloud, because it's just not going to be it's going to be cost prohibitive, basically on a per port basis when it comes to building out that infrastructure. Enterprises, developers, and one-off projects. Now, those are typically drivers as well. Again, we seem to do a lot of things within a knee-jerk reaction sometimes, and we base our projects based on the current need today. Sometimes those projects fall by the wayside, especially after newer technologies come online, and then we tend to kind of forget about what we were building. The other problem is that we also may have invested a lot of money in building out these private clouds, or building and investing into the public cloud, when we are not, as an enterprise, ready to put anything on there. So your ROI kind of flies out the window at that point as well. Firms with compute-intensive tasks. So now you're probably looking at developers, organizations that use a lot of computer graphics, that use a lot of collaborative services that need to and require to access their information from across the world. Also, if they're doing very, very high-intensive computing. Web hosting, that's the other one. Leveraging, infrastructure as a service. So if you're hosting your own service, everybody used to, go out and farm out their web services, and all of a sudden they realize, wait, I got my own pipe now. Comcast is offering me this service, or AT&T is offering me this service. I have Metro E. I can now host my own infrastructure. I have a pair of web balancers. I can build up my own server farm. That was the thing a couple of years ago. So the proliferation of pancake servers, all of a sudden the data center became nice and full, and but not using the servers to their full capacity. So you put it behind a few web accelerators and a load balancer, and you were happy as a lark. But now you're tasked with driving down costs, and the maintenance of those machines are starting to overburden, so you're starting to collapse and consolidate that. So that's where that's leading to. And then platform as a service, being able to house that inside also provides you the elasticity to be able to provide your developers the storage and space that they need, and the speed. However, again, what is the net impact on your environment? Test and development, function and scalability testing. Require some QA. It's absolutely essential that when you are in development, just like anything else, and I'm sure I'm not saying anything that you guys don't already know, but it does beg to ask: are you properly testing the applications against what the end result should be? If you're in creating a test cloud, are you fully testing the functionality of that cloud based on your applications, based on your use case, based on the needs of the environment and the business driver? These are some other points that we can touch on: collaborative computing, access to shared services, again, technical computing, such as CAD drawings and so forth. So, what fits best? Best use: temporary capacity, being elastic, having elastic capacity, being able to provide that service on demand, whether it be at websites, service-oriented architecture applications, highly parallelized workloads, applications that fit within a single VM. Can be any type of self-contained x86 application. Anything subject to compliancy, wait for the best practices to evolve. These are things that you should look at when what doesn't fit, specifically to infrastructure as a service. It includes PCI compliant applications, things that you need to secure, things that require additional security components, anything performance sensitive other than the web. And I say this because, again, when you are building this type of environment, you have to have the bandwidth to support that environment, and also have to be able to have the hardware to provide that environment as well. So when your user base goes out and tries to grab an application or tries to log into, whether it be a cloud-based Citrix or VM share or Hyper-V, are they able to get that in a relatively short period of time, or is there going to be some type of lag point? That's going to create a backlash from your user base, and you probably hear it all day long from them that stuff is not getting done and productivity is down because the service is slow. Apps that call back for performance-sensitive services, apps that require tight coupling between instances, sensitive clusters, Oracle, such large applications that don't fit inside VMwares. So things that you should take a look at when you start talking about cloud computing, and these are just top of mind. You should do test and development, functional and performance testing, certainly. Choose web and VM-ready applications, temporary and or volatile websites. So basically, if you have something that you need to work on, marketing collaboration sites are the easiest. Make sure you take responsibility for security yourself. Again, these are things that I'd like to push. Security. Today, everybody and their grandmother seems to have a rootkit of some sort, and all the instructions on how to breach a network sits out on the web, readily available. And because bandwidth is so easily attainable now these days, it is not hard to spoof someone's environment and go out and cause some sort of ruckus on the environments. Create a class technical HPC products, loosely coupled with applications that work best. Anonymize any customer-sensitive data. So you want to make sure that you protect your environment and you protect your data as well. So now we get to the enterprise. So what do we look for as far as cloud-based services on the enterprise? You want to look at applications and processes that have highly variable demand. You don't want to go after that one application that maybe a handful of people use. You want to go after something that many, many people use. At that point, it becomes much more of a value proposition versus a niche play. Initial data center capacity limits that are being reached. If your data center is being tasked and you're unable to support it, this is a good fit. Hardware that is end of its serviceable life. Again, we were talking about having that big web farm with a lot of pancake servers, and all of a sudden, your maintenance is coming due. You're 5 years down the road on these boxes. You don't want to procure anymore. What do? It may be a good fit to go ahead and just push that service off into the cloud. And your data center no longer offers you a competitive advantage to your organization. No longer provides the differentiation that you seek, and competitors' time to market surpasses yours. So you're slowing down, they're speeding up. And again, in-house application development. If you have a team of web developers or application developers, it may be essential to have that platform as a service so that you can provide them the means by which to build quicker and collaborate more efficiently, thus providing that mean time to market at a much quicker pace. That way your competitors don't outgun you. So real quickly, we look at what the clouds kind of talk about as far as models and some of the requirements. So you look at internal clouds. Internal clouds require a streamlined OpEx. Internal cloud, personal, hardware, and TC. Software, facilities, power. So you're going to have server CapEx. You're going to have storage CapEx. All those fall on the shoulders of the environment and those responsible for maintaining it, and then the management team that's responsible for putting it in and sponsoring that project. The others being hosted dedicated clouds. So you're going out to a service that you rent. So now you're avoiding the OpEx that is required to maintain all those devices, but you still have a dedicated cloud, but you still have to pay for the software, and you avoided the capital expense of having to ramp up and purchase all that hardware. Public clouds, again, similar situation. You're kind of avoiding the OpEx. Again, public cloud, you're kind of sacrificing the lamb there, basically robbing Peter to pay Paul, so you can provide your services up there, and you're taking a gamble as whether or not that service is secure. For the most part, they are secure, but again, you are basically putting your faith into their hands. The control is not yours. And again, you avoid that CapEx as far as acquiring all of that hardware, all of those services out there. I think this is a very key slide as far as this presentation is concerned, and as far as cloud and any other service is concerned. We need to align your goals across your organization. Having abstract goals only further hinders the performance of the project and the performance of the overall deliverable. So when you are ready or are implementing the cloud, you should consider, why are you moving to the cloud, and whether your goals are common across the enterprise. It doesn't make sense that finance and HR might be interested in the cloud whereas development may not have that need, and development may be the ones that necessarily need it, but maybe they don't know, or maybe it hasn't been discussed across the global enterprise. You might be missing out on certain user bases that may or may not be ready for this, and you implement something, and you're going to have a firestorm of people just coming back at you and saying, "Hey, this is not something we wanted. Performance is real poor. No one bothered to ask us about what we needed or what our problems are." That typically does happen in really large organizations. I like to believe that most organizations are in touch with the pulse of the user base, but a lot of times those get left out. So additional capacity, how much capacity? Do you need it during normal and peak times? These are things you have to ask yourself, whether you either build your cloud or you rent your cloud. Reason being is, if you don't really need it when it's not peak time, then maybe you should consider doing it and outsourcing it, because now you're still paying for power whether or not it's getting used. You're paying for cooling whether or not it's getting used. You're paying for the space whether or not it's getting used. Those are things that you need to ask yourself. Improved end user experience. What performance goals are we trying to deliver against? What is the customer asking for? What are you trying to deliver, whether it's your internal customer or your external customer? Greater elasticity. How quickly can the provider we select ramp up and meet our needs? That is very critical, because if you have a product, if you have an application or a service that you want to deliver to your user base, and the organization that you're outsourcing to is unable to meet or deliver your demands without some prolonged process, that is going to hinder your revenue stream. It is very essential that you get in front of this moving freight train before you even sign the first paper and say, okay, what is the process for onboarding new applications? What is the process for onboarding new services? Is it something that's going to take, act of God by moving mountains, or is this something that we can do just by, opening up a ticket or just signing a new contract? Flexible bursting. How fast do you need to be and able to access additional capacity? This relates more to the public cloud and more to the hosted informational cloud. Basically, if you are capped at a specific speed, you might have a provision in there that allows you to burst, whether it be 250 meg, to whatever the number may be. That allows you that flexibility of being able to say, yes, when my server base becomes more in tuned or much more users come online, and you have this specific burstable times, whether it be logon time or Christmas time or holiday time, those may be the requirements that you need to find out ahead of time. You don't want to sign a contract and then find out that every time you burst, it's going to cost you X thousands of dollars. You want to make sure that there is a provision in there that says, hey, if I burst, it's okay so long as I'm not bursting for 24 hours. Or you may provision, maybe there's a cap as to how far you can burst. But understanding that requirement, understanding what needs to be delivered, and your workload or your onboarding process will help mitigate any of these problems. So you take a look at on how to evaluate a vendor. This I have found personally, when you test vendors to 10 to 15% above estimated capacity goals, you should be able to ask them and say, okay, what is your capacity for this provision service? what is the deliverable for this provision service? And if we were to burst to this number, is it going to fail? Is it going to falter? The elasticity again, baseline the end user performance before, during, and after testing. Test your configuration settings explicitly. Try to ramp up the elasticity testing to peak levels. So basically throttle it to full bore, that way you know what your baseline is going to be. And then for burstability, you want to isolate the cloud elements from other infrastructure so you can test. So you don't want to you don't want to combine everything and then say, okay, this is what's going to happen, this is the net result. You want to find out if there's a specific application out there that's actually going to cause you to go over. And then you want to test, and this is a critical test for all clouds, test the failover process. Not testing the failover process is just a recipe for disaster, because you're actually waiting for something to happen and then not know if it's actually going to work. So best practice SLAs, this I took from IDC, and basically they said set SLAs based on your goals, end user availability and response times, capacity and elasticity objectives, and burstability goals, transactional success rate, fast end user experience across key geographies for software as a service. Platform as a service, you want availability, performance of key components, services, and APIs. So basically, you want to be able to monitor those numbers, be able to slap them against each other, and compare that you are actually getting a benefit to it. And then for infrastructure as a service, this one is key because it requires a personal investment. Hardware and operating system availability, performance, and network connectivity. Network connectivity is very critical. Again, the old plumbing doesn't necessarily work with housing your own cloud-based service. It certainly doesn't really matter if you're going out and renting the cloud, but if you're providing your own cloud and you're expecting to tap into that cloud from that legacy environment, you might run into a problem. Okay, so key attributes. You want shared standard service built for market public, not single customer. So basically, you don't want to target just a group of individuals. You want to target your entire base. It has to make sense. It has to. You have to understand whether or not this is something that's sustainable by the entire enterprises, and if the entire enterprise is going to adopt it and use it. Because if it's not, then you're losing money. Solution package. Is it a turnkey offering? Do they have any level? What's the level of integration? Self-service. Who's your admin? Who's your provisioning? Require some onboarding support. Do you understand what that process is? Your scaling, dynamic and fine-grained. Do you understand how fast you can do it and what actually can be tuned to it? Rest is use-based scaling, accessible via the internet, standard UI technologies, and published service interfaces, whether it be an API or what have you. How are you going to access this? Your deployment model, again, public or private. I think we've talked about that ad nauseum. But obviously, if you're a smaller organization and you're looking to move up and you're not quite sure if you're ready for cloud computing, public may be the way to go. Private is if you're ready, you have the infrastructure, you have a plan in place, you have talked to all your constituencies, you understand what the needs are and the business drivers are, and you're ready to make that leap. So, just to give you an example of what these, who's providing what and where they're providing it, cloud-based applications. We all know Salesforce, Google Apps, Microsoft, etc. That comes down to cloud application platforms, whether it be, again, Force.com, Google, WebEx Connect, Intuit. And then we talk about cloud infrastructure. Infrastructure as a service, where they provide you Amazon, AT&T, Sun, all those organizations can help you ramp up with cloud as infrastructure as a service. A couple of other, flowcharts regarding cloud applications or apps as a service, collaborative applications, content applications, enterprise resource management. I think you get the drift on that. Cloud application platforms, platforms as a service. Again, development. That's the key word. Your developers require lots of speeds and feeds. They require a system that's unique to them and one that they can easily collaborate across. Systems infrastructure software and system storage kind of sits in between, but then you talk about just systems and storage, infrastructure as a service. That's where the nitty-gritty comes in again, and where I've seen personally the greatest deal of angst when it relates to systems and storage. How do we combine those two mediums together in the cloud, and how do we make sure that it's cost effective, that it's readily? so readily available. And you have to understand, again, you have to assess your environment. You have to look at what your legacy network is capable of, and if you need to build out, perhaps it may be time for a refresh, or it may be time for a procurement of a separate environment altogether, and then renting that space out to put that environment in, or if you have the space, putting it in there. Cloud-based businesses, again, everybody uses them. We use them all today, whether it be FedEx, UPS, PayPal, transactions, things that happen at a global scale very fast, very quickly. You notice that those services are always on. These organizations have gone through great depths to provide this infrastructure so that we may access it and do so in a safe manner. However, it didn't come easily. PayPal used to suffer. FedEx had its ups and downs. Amazon certainly had its hiccups. They took their lumps as far as offering these services, but now they've stabilized, and it's taken them many years to get there. So it's not a quick fix service. So the last topic we're going to talk about is talking about security and what controls do we lose when we use the cloud. So whether it's SaaS or IaaS and etc. So physical and logical network barriers. Where do you have your firewalls? Where do you have your access lists? Endpoint restrictions and management. Again, who is accessing the service? Are they properly authenticated to the environment? Are they supposed to be on the environment? These are questions that you need to ask of your management base and those managing the laptops, the web-based devices, be it pads or phones, what have you. Those are things you need to take a look at, because typically, if there's going to be a breach, 9 times out of 10, it's going to happen from that regards. They're going to VPN into the environment, and they're going to have something on there that you really don't want. Non-password authentication. Again, you're trusting that when you're accessing it's a secure environment, and if you're already onto the environment and all you have to do is just press a button, who's accessing it and what authority do they have? Fine-rate credential quality controls and password reset process, who's managing that? And real-time anomaly detection, how do you get that? Is your provider going to have that for you? Probably not, because they're so busy looking at everybody else's environments, it would be just difficult to go ahead and specifically narrow down to you. They're getting better now these days. However, way behind. There's a gentleman that I follow on Twitter, at Beaker is his handle. He's a Juniper security analyst, and he's highly touted and highly wide regarded in the security space. But he talks about automation and automation within environments, specifically cloud-based environments. As long as we have to continue to do this, to do security parameters and security policies manually, we're going to have a hard time keeping up with the Joneses, so to speak. Basically, hackers are fast, and they're faster. Security is reactive. It's slower. How do we bridge that gap? We're looking at automation. I think at some point down the line, we're going to see a greater deal of integration and automation with these services, and I hope it comes sooner than later, because the gap is starting to get wider. Most IT departments believe in some of these. Many people doubt usefulness of the perimeter, putting actually security on the outside. Everybody thinks if you secure the inside, you don't secure the outside. You don't have to necessarily secure the outside as once before. And hackers aren't unicorns. This is definitely true. This is what I'm telling you. And my experience has seen anything is that hackers are very quick and agile. They are well funded and they are well motivated. They have something that's pent up in them, and they're getting money to release it, and they have no qualms because it is a faceless individual, a faceless act. So by definition, the anonymity that is produced by the internet that secures us for the most part also empowers them. And that is the great dichotomy between security, between a hacker and a user. The anonymity provides you that wherewithal of having that feel I'm safe sensation. So when you look at applying cloud, you're applying security to clouds, a lot of people will say, well, it kind of defeats the purpose of having a cloud, and it kind of defeats the purpose of having an open-ended environment. Just the other day, I was looking at some cloud-based services, and I noticed that there's a service that's going to be offered on one of these bigger services, and it's Tor, onion routing. For a capped bandwidth, certainly to get around, but it's to hide you and provide anonymity access through the cloud. How interesting is that? As a security individual, that kind of scares me, because now we're talking about allowing onion routing or Tor-based services within the cloud. So that with that out there, how do we know what's bouncing in and outside of the cloud? We don't, so we have to take additional precautions, and we have to follow our own security models. That's very important when you deploy any situation or any solution set, is that you have to make sure that your security model it closely ties and mirrors to the policies of the organization. Now, I talk about policies because policies are the driving force behind those security rules and sets. If you don't have policy that is handled and managed through management, and has buy-in through the user base, it's going to be difficult to implement, and it's going to be difficult to maintain. So what does security mean in the cloud? It allows you to use alternative credibility schemas, whether it be token or certificates. Yes, it's not as quick as just pressing the button and you're accessing it, but it does solve the authentication problem. Completely control password policies. Yes, if you're outsourcing that, you may not have that granular control, but maybe that's something you can negotiate up front. Implement internal password resets. Perform anomaly detection on login attempts. Certainly you can do that. Place the portal behind the VPN access control. So maybe that's something you can explore, is where does your portal sit? Is it sitting on the web? Is it sitting on a DMZ? Do you house the portal internally? And then endpoint management, again, critical, being able to have some type of service that's running on your smartphone or web tablet for cloud-based services, and being able to monitor and manage and mitigate malware, antivirus, any VPN type of access. My recommendation on this is implement strong policies on quality and rotation. So basically, your username, your passwords need to change. Your policies should be reviewed on a quarterly or yearly basis to make sure you are keeping up with what's being implemented. Employee education is key. An educated customer is our best customer is one of the commercials I hear on the radio all the time, and it is so true, especially when it comes to security. If you do not inform your user base of security breaches or security problems, they will never know what not to look for. This was especially prevalent back in the early 2000s with all these phishing scams that still occur. People just opened up web pages after web pages on emails without even having a forethought, and next thing you know, they were being cross-scripted, or somebody was accessing their information, installing keyloggers and what have you. Never reuse credentials. Make sure that your system is capable of rejecting reused keys or credentials. Anti-phishing techniques. Use offsite SSO if single sign-on if possible. So basically, don't house it on the same system. Consider additional restrictions using VPN, and map to what protections you had before the cloud. So again, if you had a policy, if you had a procedure, if you had anything that was enforced, make sure that when you move over to the cloud, that it mirrors to what you had before. And if not, we can certainly help you get there. That has been the cloud in a nutshell from my perspective on why clouds are difficult to implement, but why clouds can be very useful to your environment. I highly suggest that you, if you have time to look us up, if not, go out on the web and do some research on the web. IDC has a wonderful, wonderful white paper on cloud computing. Also, Black Hack forums also have many different white papers on cloud security. But if you have any questions, we'd be more than happy to answer them for you. I thank you for your time. Please connect with us. Come visit us at jsolve.com or structure-tech.com, or visit us on Twitter or YouTube. Thank you very much, and have a wonderful day.